class.
This presentation discusses infinite limits and limits to infinity by first describing what is a limit. Hi, my name is Pam, and I'm going to discuss today what is a limit and give a definition for it. There. Mathematically, a limit is the value of a function or sequence approaches as an input or index approaches some value. But the limit cannot or should not exceed the value. We have a circle which has no polygon inside of it. As the area of the polygon gets larger, the area of the circle is going smaller. And as you can see, here we have it where the area also grew inside the square even larger. The circle is growing smaller of the area of it. But as you continue going and it keeps increasing, this keeps decreasing. The circle keeps decreasing. And as that happens, the area of the polygon is taking and getting closer and closer. It is approaching the area of the circle, but it can never actually reach the circle no matter how many more sides we add to it. But as the area of the polygon starts to get smaller, the area of the circle starts to increase. So the area of the polygon is decreasing and the area of the circle is increasing. That explains what a limit is.
Hi, my name is Blake, and today we're going to examine the limits at infinity. So the definition of limits at infinity: as x approaches positive or negative infinity, the function f of x approaches a finite number but never reaches this number. Graphically, we can look at this by, as x approaches 0 in this instance, it's going to get closer and closer, but it never reaches it, and it goes out infinitely, positively and negatively. As x approaches positive or negative infinity of 100 over x, we're going to approach 0, but we'll never reach 0. So, for instance, if we had 100 over x, as x approaches 1, it'd be 100. As x gets larger and larger, 2, 4, 1,000, or to 1 million, your value is going to get smaller and smaller and smaller. So if we had a $100 bill and we divided it by one person, we would have, that person would get $100. The more and more people we divide it by, the less and less each person gets. We're going to examine if we had a $100 bill and we're going to divide it by more and more people. So the function of 100 over x represents our $100 bill being divided by more and more people as x approaches positive infinity. As x gets larger and larger towards infinity, our function is going to approach 0. So if we had a $100 bill and we divided it by one person, that one person would get $100. If we had a $100 bill divided by two people, that one person, but they'd each get $50. As x gets larger and larger, each person is going to receive less and less of that $100 bill.
I'm Jonathan, and I'll be teaching you guys about infinite limits. So we have infinite limits. For example, we have a limit as x approaches negative 3 of f of x, where f of x equals x minus 5 over x plus 3. Traditionally with a limit, we would just plug it in there and evaluate it. So if we plug this in, we would get that that it equals negative 8 over 0. Now this is normally undefined right here. But keep in mind that as a limit, since this is a limit, it never actually approaches this number, which is 3. For example, we have this nice little chart drawn out here to show that, so as x gets closer and closer to 3 from each side, this number is going to get larger and larger. So instead of plugging in 3 here, we can just plug in, let's see, as x equals negative 2.999, because this number is pretty close to 3 without actually touching negative 3. So we would plug that in as We see as that we plugged in this number really close to negative 3, and we get a negative large number. Back to the chart, we did this several times with numbers getting closer and closer to 3 each time. Conclude that as this number gets closer and closer to negative 3, from the right side, it's going to be negative infinity. And as it approaches from the left side, we get positive infinity because we're getting closer. And our numbers are coming out arbitrarily large on the positive side. So as you can see, as we approach negative 3 from the left side, we are getting positive infinity because this number is getting larger and larger each time we get closer and closer to negative 3. And as we approach from the right side, we can tell that this is negative infinity because we are getting a larger and larger number on the negative side as we get closer and closer to negative 3.
This video concludes what's a limit at infinity, and infinite limits. For more information, attend a calculus class or look on the internet.